The ribbon microphone was invented in the 1920s and first commercially produced in 1931. It's called a ribbon microphone because inside, a thin aluminum ribbon positioned between two magnets converts sound waves into electrical signals. Introduced in 1931, ribbon microphones revolutionized the broadcasting and audio recording industries with unprecedented sound quality. This company manufactures a modern version of the RCA-44, one of the first ribbon microphones. This manufacturer handcrafts the microphone, starting with the frame which holds all the components. After cutting a flat piece of brass, the machinist makes two bends with a press, then drills threaded holes for the fasteners, which will connect the frame to the rest of the microphone. He puts the bar into another press, which bends the two ends upward to form a U shape. The frame goes off to another department to be chrome-plated and polished. Meanwhile, another machinist takes a sheet of perforated brass to begin forming the microphone's signature grill. He secures it to a die with two mounting plates. The die is the shape of one half of the multi-sided grill. He mounts it onto a fly press, a press operated by rotating a heavy counterweight. As that counterweight spins, the die descends into a forming mold that's also in the shape of half of the grill. A high-speed automated cutter trims the perimeter to make a neat, even edge all around. Then the grill halves are sent off to be chrome-plated and polished. Next, a technician assembles the motor, the heart of the microphone. First, he snaps on two strong magnets. The gap between them is where he'll later insert the key component, the thin aluminum ribbon, which gives this type of microphone its name. After aligning the top of the motor with the bottom, he attaches the frame, which has since acquired a custom-made transformer, electrical terminals, and side brackets. Now for that all-important ribbon. A technician crafts it from a hair-thin sheet of pure aluminum. It's so fragile, he has to handle it with tweezers. First, using the edge of a razor blade, he glues down the edges to a thin sheet of paper set on a glass cutting surface. Then he places a second sheet of paper on top, and with a razor blade, slices lengthwise, dividing it into 4 ribbons, each 4.5 millimeters wide. When sound waves pass through the microphone, they cause minute differences in air pressure between the front and back of the ribbon inside. This causes the ribbon to move in response to the peaks and valleys of the sound wave. The technician corrugates the ribbon so that it responds to these minute air pressure changes more accurately. He removes the protective papers and installs the ribbon in the motor between the two magnets. In this position, the moving ribbon is a conductor in a magnetic field, generating a tiny current, an electrical replica of the sound wave that can be recorded, amplified, or broadcasted. A technician tests the ribbon's tension to ensure it's neither too tight nor too loose. He hooks up the terminals to an audio signal generator and measures at what frequency the ribbon resonates. If necessary, he tunes the ribbon by adjusting its tension. He installs what's called a puff shield. It prevents puffs of air from stretching or tearing the delicate ribbon. A 2-part metal housing will encase the lower part of the motor. However, before assembling it, a technician glues on an embossed metal medallion bearing the company's logo. Then he takes the motor, which by now has acquired an output cable, stands it upside down, and assembles the housing around it. Then he turns it right side up and assembles the two halves of the grill. A sleek-looking chrome-plated band hides the joint. He fastens the microphone to a U-shaped stand called a yoke. On each side, there's a thumb nut, which you loosen to tilt the mic, then tighten to lock the position. Although newer technologies have emerged since, the classic ribbon microphone still remains a favorite of sound engineers around the world.